You want to prove this statement by mathematical induction. It says the sum from r equals 1 to n of 2r minus 1 is equal to n squared. I'm going to ask you to pause the video and prove it. Okay, you finished? Alright, so let's work it out. First step, we're going to show that P1 is true. So you start off right from 1. So therefore, in this case, is n is equal to 1. You change n to 1. So in this case, 2 and r would be 1 minus 1 is equal to 1 squared. 2 ones, 2 minus 1 is 1. So we see both sides are the same. Here, you don't need to show that P2 is true. But suppose we do it anyway, what would happen? You would have, now remember, at each point, r changes to a different number. In the first term, r is 1, so it's 2 times 1 minus 1 plus. In the second term, r is 2, so it's 2 times 2 minus 1. Alright. In this case, n is the number where you stop counting, the nth term. So it's going to be 2 squared. 2 ones, 2 minus 1, plus 2 twos, 4 minus 1. This would be 2 minus 1 is 1, plus 3 is equal to 4. We see 2 squared is 4. Alright? So you see that? We show that P2 is true, but you don't need to do it in exam, test, homework, assignments, whatever the case is. Or you must show that P1 is true. If you want to show P3, just to see if it really works, and to show the pattern here. If P3 is true, to show that P3 is 2, remember, R is going to be in first term is 1, 2 by 1 minus 1 plus. The second term, R is 2, 2 times 2 minus 1 plus. In the third term, R is 3, 2 times 3 minus 1 is equal to, now, here, n is the last term. It is the third term, right? So it's going to be 3 squared. The right hand, what am I writing for? The right hand side says 9. 3 squared is 9. Let's see what we get on the left hand side if it's the same thing. 2 times 1 is 2 minus 1. 2 minus 1 is 1 plus. 2 times 2 is 4. 4 minus 1 is 3. So it's 3 plus. 2 times 3 is 6. 6 minus 1 is 5. So this is 5. Alright. 5 and 3, 8 and 1, 9. So 9 is equal to 9. Right? You could show that P4 is true, P5 is true, right? Just as practice. But the thing is, you don't need to do that in your exam, test, class test, homework assignments, and so on. What you need to do is show that P1 is true, which we did earlier, alright? Now, that's the first step. The second step is to assume that PK is true. Now remember, you're assuming that PK is true. So that means the sum from r equals 1 to k of 2r minus 1 is equal to, in this case, is k squared. Now remember, if you show that P1 is true, that's all well and good. I can ask you then, what about 2? Show that P2 is true. Good, but question is, what about P3? And so on and so forth, right? If you show that P10 is true, the problem is you did not show that the number before it, which is P9, is true, and you did not show that the number after it is, which is P11, is true. So you cannot use a specific number here. If you use a specific number, then you'd have to show that the numbers before it are true and the numbers after it are true. And there's an unlimited number of numbers here. So you cannot point to any specific number. What you do is point to something that represents any number. In this case, K, the letter K. So you show that the sum from R equal 1 to K is true. You already show that P1 is true, but probably K is 2. And if you say you show that PK is P2 is true, then maybe K is 3. Alright? So by using K, you don't use a specific number, but it can be any number. So you covered, basically you cover all numbers. Alright? But then, when you show that PK is true, that particular number, whatever number it is, that's where you stop. The question is, what happened to the number after? Alright, so the number after. Don't forget the number after. What you will do is prove that PK plus 1 is true. The number after K is K plus 1. So you must show that one. Alright? So here, you're summing from R is equal to 1 to K plus 1 of 2R minus 1 is equal to, well, K plus 1, it's stopping at K plus 1, so N becomes K plus 1. And you have your square here, alright? Now, what you're going to do is say that since you're adding from R equal 1 to K plus 1, is the same thing as R equal 1, adding from R equal 1 to K, and then adding the K plus 1 term. Alright? So, you're going to have two parts to this. You're summing from R equal 1 to K of 2R minus 1 plus the K plus 1 term. And that will be equal to K plus 1 squared. It's similar to saying that you're summing from, say, 1 to 6. 1 plus 2 plus 3 plus 4 plus 5 plus 6. It's similar to adding from 1 to 5, and then later on you add the 6th term. Now what is the 6th term? Well, 6 is 5 plus 1. So this is a 5 plus 1 term. Alright? So in this case, you're adding up from 1 to K. Then you add the number that comes after K, which is, or the term, you add the term that comes after K, which is the K plus 1 term. So you add 1, 2 plus 2 plus 3 plus 4 plus 5. Then you add the number that comes after 5, which is the 5 plus 1 number, which is the 6th number, right? So, let's see how this goes. Now, you see this part, you're going to write it in this form. When you sum from R equal 1 to K of 2R minus 1, you get N squared. So if you sum from, let me say that again. If you sum from R equal 1 to N of 2R minus 1, you get N squared. So this N squared. If you sum from R equal 1 to K of 2R minus 1, you get, well, it would be K squared. Alright? Plus now, the k plus 1's term. What is the k plus 1's term? Remember, the first term is 2 times 1 minus 1. The second term is 2 times 2 minus 1. The third term is 2 times 3 minus 1. So the nth term is 2 times n minus 1. 2 times the position minus 1. So the k plus 1 term would be 2 times k plus 1 minus 1. That's the k plus 1's term. Alright? And that's k equal to k plus 1 squared. See that? Now, here, you have k squared plus, alright, 2 times k plus 1 minus 1. Multiply. 2 times k is 2k. 2 times 1 is plus 2 minus 1 equals k plus 1 squared. But here, 2 minus 1 is 1. So I can write this as plus 1. Alright. Now, you can change one side to make it look like the other side. You could factorize this to make it look like k plus 1, or you could multiply with the brackets to make it look like k squared plus 2k plus 1. Now, suppose we multiply with the brackets. We would have k plus 1 times k plus 1. So, we would have k squared plus k plus k plus 1 times 1 gives you 1. So it's k squared plus 2k plus 1. Same thing as this, alright? So you prove it. Now, as I said before, another way to prove it is to factorize here. Now, if you have been practicing your factorization of quadratic expressions, then you wouldn't have to run away from factorizing, alright? You would know exactly what you're doing. A is 1, B is 2, C is 1. And this is on the quadratic expression in K. So 1 times 1 is equal to 1. You find two numbers that multiply and give you 1 and add to give you 2. That's 1 and 1. So you say k squared plus 1k plus 1k. You separate the 2k into 1k plus 1k plus 1. Group and factorize, you have k outside the bracket, k plus 1 inside the bracket, plus 1, k plus 1. Alright? That's equal to k plus 1 squared. So, factorize, you have k plus 1, you have k plus 1, k plus 1. But k plus 1 by k plus 1 is k plus 1 squared. So k plus 1 squared is equal to k plus 1 squared. And that's the other way that you could prove it. So once you're done, whichever method you use, once you're done, you can write prove.